All right, so I'm going to go over examples over the section Algebraic and Congruence Properties. Make sure that in your notes previous to this, you should see an attachment that has a table of all the properties of equality filled out. So before you even start here, you want to make sure that you have that and you've looked it over. So when I take a look at this first example here, right, oftentimes you guys know how to solve this equation. Most of us can just look at that and solve it. But now what I'm going to ask for you guys to do when you prepare for proof writing is to justify each step. So now you've got to exactly tell me what did you do from step 1 to step 2 using your list of properties of equality. If it helps, sometimes look at how it was worked out and try to fill in the gaps for what was written. So for example, from, let's see, step 1 is always going to be given, generally. So if I'm not sure about what happens from 1 to 2, 2 to 3, 3 to 4, so on and so forth, right? I draw in the steps myself, so it looks like this person distributed. Then they combined like terms. Looks like this x then moved over here. Then the 3 moved from left to right, and they're redivided. If it helps you, fill in those steps because those will be your hints to figure out what happened, what was the justification. So step 1 is always given. From 1 to 2, the person distributed. 2 to 3, looks like there was a combining of like terms, or I like to say just simplify. 3 to 4, they subtracted. POE, remember, means property of equality. From 4 to 5, again, that's subtraction. We subtracted both sides, so it's subtraction, property of equality. And then from 5 to 6, we divided both sides by 5, so that's the division, property of equality. Now, sometimes I'm going to throw in geometric equations that are influenced by algebra. So, if the measure of angle A plus the measure of angle B equals 100 degrees, and the measure of angle B is 40, prove that angle A is an acute angle. Generally, the first one is given. Measure of angle B is 40. Actually, that was given to us as well, so that's actually given. So given can appear later in the proof, multiple times. And then we have this substitution. It's a substitution of line 2 into line 1. I'll let you take a look at that and see if you realize what just happened. The next one, the 40 disappeared. How did it disappear? It looks like they subtracted 40. So if it's a subtraction of 40, this is the subtraction property of equality. And so we end up with the measure of angle A is 60 degrees, and they say angle A is an acute angle. So here's where we pull in some geometric proof or reasoning. That's the definition of acute angles. Next proof is a little trickier. Given points A, B, and C with AB equal 8, BC equals 17, and AC equal to 20, are A, B, and C collinear? So let's start off with what was given to us. We know that AB equals 8, BC equals 17, and AC equals 20. One here, one here. So that was given. Now the hint says set up an equation using segment addition postulate. So they're trying to tell us that we want to add these pieces together. So step 2 would be something like AB plus BC equals AC. And the reason is segment addition postulate. So again, if you don't remember, that's the abbreviation for segment addition postulate from the first chapter. So let's substitute the numbers in, because if this is going to be true, then they should add up, right? So 8 plus 17 equals 20. This is the substitution. Property of equality, we substituted line 1 into line 2. Clean it up. So we simplified. Oops, the wrong number up here. That should have been a 3. Here's 4. So simplify. And then we have what happens is a contradiction occurs. So line 5. Our contradiction is that 25 does not equal 20, right? Thus, points A, B, C are not collinear. Some more two-column proofs. Let's see, two-column proof. If A, B, C, and D are points on a line in the given order, then AB equals C and AB equals CD, then AC equals BD. Now, if it helps, right, if there's no picture provided, make sure that you draw one. So they tell us A, B, C, D are points on a line in that order. And they say that AB is equal to CD. Now, they have all the statements worked out for us. We just got to come up with the justifications. So for line 1, that's given. That was given to us here. And AB equals CD is given as well. When something is equal to itself, we say reflexive. Right? So they're saying that BC is equal to itself. And then they're going to add. So they're using the addition. This one's a little tricky. They're adding BC to both sides. And then that allows us to combine with SAT, because we already know that they're all on the same line, and we've proven what we needed to prove. A couple of things to keep in mind. Make sure you number each step. Always start with what's given with you. Sometimes the given is explicit, meaning it's written out. Sometimes it's in a picture, right? They give you a picture and there's some markings on it. Statements with the same reason can be combined. It's totally up to you. Generally, I don't. On tests, I don't combine, so that way it doesn't become confusing. If you have a picture or if you don't, you should draw one and then mark it. You should have a reason for every step, and generally, there's some parts of a proof where the order doesn't matter. All right, so properties of congruence. Just as a little side note, what does it look? A reflexive property of congruence for angles would look something like this. So remember, reflexive usually means it's equal to itself. For segments, AB is congruent to AB. Sometimes you can remember the order can switch. Symmetric property. So if angle YEP is congruent to angle SIL, then angle SIL is congruent to angle YEP. For segments, it's if segment KV equals congruent to AM, then segment AM is congruent to segment KV. And then if angle A is congruent to angle B and angle B congruent to angle C, then angle A is congruent to angle C. If segment AB is congruent to segment BC and segment CD congruent to EF, sorry, this is D, then AB congruent to EF. And then another side one, this is probably the one that gets used most. Congruent objects. Objects are congruent only if they have the same measure. So you can just say congruent objects, or you can say the whole statement. Just remember that if objects are congruent, then they have congruent measures.